So this is the CFEngine presentation, automating database system administration with CFEngine. My name is Aleksey. My name is Aleksey Tsalolikhin. I'm a Unix and Linux system administrator, and I support Postgres databases from that hat. Very interested in automating system administration, so instead of making changes to your servers one by hand, you use policy-based system administration where you write a policy that describes what your system should look like, and then you have some automated tool that checks the actual state of the system compared to your desired state, and if necessary, reconciles that state. So I do training on CFEngine, which is this program that does that. If you have any questions, here's my email address, aleksey@verticalsysadmin.com. Have more information on CFEngine at my website, www.verticalsysadmin.com. Let me show you what I have. So first I'm going to make sure I have a clean slate. I'm removing PostgreSQL-server package, shutting down the database, so we have a completely clean slate to start. I'm using CentOS for my demonstration since Linux is so popular today, and Red Hat is a very popular version of Linux, so it seems to have a very broad coverage. Can I just see a show of hands here? How many of you are running some kind of Red Hat Linux system? So I have maybe 3/4 of the room. Thank you. So here we go. I'm removing PostgreSQL and PostgreSQL-server. So nothing up my sleeve. PostgreSQL is not running. So what I'm going to do here is, the way CFEngine works is, the idea is you write a policy that describes the desired configuration of your system. And then CFEngine will take that policy and will look at your system, will compare it to the policy, and when it finds deviations, it will attempt to fix them. So the idea is, instead of making changes to each system one by one manually, is you write a policy, and then you have an automated system for monitoring that policy and enforcing that policy. So this saves tremendous labor when you get into tens, hundreds, thousands, tens of thousands of servers. Increases the ratio of how many servers you can have per system administrator, and frees up the system administrator to do more interesting work than routine work. If you configure a database server, then you have to configure another one and another one. It's pretty cookie cutter. Well, it's easier to just tell the computer how to do it and have the computer do it. So this is what we're going to do here. We're going to have the computer do it. If anybody has any questions, please feel free. I do take questions during the presentation. So this is my policy file. And if anybody wants, it's available online. I'm going to post it after the presentation. www.verticalsysadmin.com/CFEngine/CFEngine_examples.tar. If you go to verticalsysadmin.com/CFEngine, you'll find a lot of things, including these examples. So I'm going to have to make this just a little bit smaller so it fits on the screen. Can you still read that? Yep. Okay, good. Okay. So this first section is the control section. So this controls the running behavior of CFEngine. It controls CFEngine's own behavior. So first we specify a version of our policy. And this can be any text string. So I put in a numeric version identifier and a date. And then I'm using some commercial extensions to CFEngine. CFEngine has been open source since 1993. So it's still open source, but the last couple of years there's a company, CFEngine AS, out of Norway, with CFEngine Incorporated, a US subsidiary that supports the development of CFEngine and provides support, commercial support 24/7 for CFEngine. And they've added some functionality, and they've added database functionality, which is what I'm going to be demonstrating today. So this host license is paid 10. It relates to the enterprise bit of CFEngine. So this specifies inputs, input files. This is the standard library for CFEngine. So finally, here is our bundle sequence. So in CFEngine language, you have the way you describe your configuration, your system configuration, you describe it using a declarative language. So you don't say install this package. You say this package is installed. And the reason for that is how you install a package is different from system to system and from OS to OS. And CFEngine's job is to abstract those differences from you and to take care of them for you. So when you say this package is installed, that's a promise. So the idea is this package promises to be installed. And it doesn't guarantee it, because in the real world, you cannot guarantee something will be the case, because there's some external dependencies. Perhaps that you're loading the package from an external database, an external repository, and that repository is down today because they're having some problems. So you can't guarantee that a package will be installed, but you can promise that you will try to install it. So this is the model that CFEngine is based on. It's the promise model. It's a very practical approach, and there is some logic and math behind it, some scientific papers. But for our use, it's enough to say that it's a promise, and I'll show you how it works. So promises are grouped into bundles. You have bundles of promises. So a bundle is a collection of one or more promises that has a name. Here we specify a sequence of bundles. That's the order in which these bundles will be examined and action taken to make the system match the stated configuration. One of the key challenges to scalability is knowledge management. So we're drowning in the sea of details. CFEngine aims to help handle that sea of details. So there's different capabilities in CFEngine to help with knowledge management. So one of the ways that you can aid knowledge management is by using descriptive bundle names. So in this example, I have a bundle that says DB cluster is installed. Now, you don't have to know anything about CFEngine to understand what this bundle is going to do. And then I have a bundle, PG-HBA-conf trusts local users. So that also should be self-explanatory. If it's not, please let me know. DB cluster is running. So it's one thing to install a package, and it's another thing to start the process. So as system administrators, the basic things that we handle are packages, files, processes, services, and CFEngine can handle all of these things. The next bundle is database exists. So you have a database cluster up, and next you create a database resident in that database cluster. And the final step is schema exists and is correct. So you've put the database cluster there, you've put a database inside that cluster, and now you create some tables in that database, and you have schema for those tables. Now, the way CFEngine operates normally is it runs continuously. By default, it runs at 5-minute intervals. It's very lightweight, has a very light footprint. When it runs all the components, the memory footprint is under 10 megabytes. It has very few dependencies. CFEngine is written in C, and it has very few dependencies, 3 libraries that it requires. So it's very nimble, has a very small footprint, and it's very portable because it's written in C. So people are using it on desktops, people are using it on servers, people are using it on supercompute clusters that are tens of thousands of nodes, and people are using it on smartphones, embedded devices. It can go lots of places. So the idea is it can be used to build a server, and it can also be used to maintain a server. So if somebody makes some unauthorized changes to your server, CFEngine will fix them to bring it back to your blueprint. How does that sound? Do you have any questions on anything I've said so far? Is it sort of what are you in the right room? Is that sort of what you were expecting? Yes?
So the bundle names, are they just the name of a configuration set, or are the names actually affecting what happens at all?
Good question. The names don't affect what happens. The name is just an identifier that you give it. And the main purpose of the identifier is you have to be able to identify if you have more than one bundle, you have to be able to differentiate them, but it's also useful to give a meaningful name. So you can see what the bundle, you can get an idea of what the bundle does without actually looking inside the bundle. So you have this idea of abstraction as enabling system administration. You don't have to deal with all these details, you just have a general summary. But those details are available to you if you need to look at them. So you can navigate these different abstraction levels, high level and low level. So here's our first bundle. This is a bundle of type agent. There's different components in CFEngine that make up the CFEngine system, different, like 10 binaries about. So the part of CFEngine that actually makes changes to your system is the agent. And the idea is each of your systems would have its own CFEngine installed and would run its own CFEngine and would have a local copy of the policy. And you can run them standalone like that, or you can network your CFEngine instances and you can have a source of the policy. So you have a policy definition point, someplace where you issue policy, and then these nodes suck up the policy and check their own system state against this central policy. So because you don't have a central point going around checking all the servers, it's very scalable. Each system takes care of handling its own configuration. So here we have a bundle of type agent, and the name is db clusters installed. Here we have a promise. Each promise starts with a promise type, which is followed by a colon. So the promise type is packages. So this identifies what aspect of the system we're dealing with. Are we dealing with packages or files or commands, or what is it? So this is a packages type promise. And then you have, in double quotes, you have a system object. This is the promiser. This is the object that's affected by the promise. So here we have a package called PostgreSQL. And then we have some attributes of that promise. And these attributes are pairs. So it's the attribute name and then the content or value of that attribute. So the package policy is, well, what do we do with this package? Do we add it? Do we delete it? Do we verify it? Do we update it? So in this case, we say add it. And the package method tells us how are we going to handle this package? What package manager are we going to use? Because there's a wide variety of package managers out there today. And you can have different package managers in play on a single operating system. So in this case, we're saying, well, this is a yum package, and it should be installed. Similarly, we specify PostgreSQL server, package policy add, package method yum, same as before. Here's something new, classes. Now, classes in CFEngine have nothing to do with object-oriented programming classes. This is the English word classes, as in a set of things or a group of things that have some characteristic in common, like a class of cars or a class of sailboats or a class of database servers. So classes are a way to group servers. And the reason it's convenient to group servers is you might want to have a policy that's not a global policy, but is specific to a group of servers. So for example, you might want to have the HTTPD package installed on your web servers and the PostgreSQL-server package installed on your database servers. So in your policy, you say, you can qualify a promise with a class, and you can say, this is a packages type promise that only applies to web servers. And then you say, go ahead and install this package. So here what we're doing is we're saying, if this promise is repaired, then define a class called start_progress. Now, what does it mean for a promise to be repaired? A promise can be in 3 states as far as CFEngine is concerned. A promise is kept. So for example, the policy states that the PostgreSQL-server package should be installed. We look in our system, and we find, yes, it's installed. OK, great. Promise is kept. That's one possible outcome. There's 2 others. Let's say the package is not installed, so CFEngine will install it. It will run a command to interface with the package manager to install the package. That package is successfully installed. That is considered a repaired promise. It wasn't kept at the start, but it was kept at the end. So we call that a repaired promise. The third possible outcome is CFEngine saw that there was no package. It ran the command to install the package, and the command exited with a non-zero status. The command failed. Maybe the network was down, maybe the remote repository was down, Maybe there was some file conflict and the package couldn't be installed. Whatever the case, we're now in the third possible outcome, which is a promise not kept. Not kept means repair was attempted and it failed. So here we're qualifying our promise to install the package. We're saying if this promise was repaired, then you define this special class called start_progress, start_Postgres. And the way it comes into play is in the very next promise. And by the way, each promise is terminated with a semicolon. In the CFEngine syntax, a complete statement is terminated with a semicolon. So what this does is this is a commands type promise. It's a promise to run a command. This is the command that we're going to run. Just start the PostgreSQL database. But there's a qualifier here, start_progress : So this command will only be run if that class is set. And that class will only be set if this promise was repaired. So in effect, what this does, yes, sir?
So is this the order in which the commands are run? I thought the Postgres server should be installed before the Postgres.
Right. It makes sense. You see, because the CFEngine language is descriptive and not imperative or procedural, what you're describing is the final state of the configuration and not how to get there. But in real life, you have to take account of these sequential steps. So I could have decoupled these two promises and just had two promises. One is that the package is installed, and the other one is that this command will be run. Because this command can be run over and over again with the same result. On the first pass, it will succeed. It will start the database. On the second pass, the second time you run it, it will fail because the database is already running, so it will fail to start the database. But the end result will be the same. The database is running. So this class is not necessary. What I'm doing here is a little bit of trying to impose some kind of sequence in a declarative language. It's not, strictly speaking, necessary. So, in fact, I will simplify this example. Well, anyway, I'll leave it as it is. So what we're doing here is this couples the two promises. So CFEngine, when it runs, it actually does 3 passes over these promises. And this allows things to click into place when there are dependencies. So it allows the system to converge very quickly from whatever its current state is to ideal state. So this is a conditional promise, and it will only be run if start_progress is set. And start_Postgres will be set only if this promise is repaired. So what will actually end up happening is after the package is installed, immediately it will run the command to start Postgres. Yes, sir? Yeah, good point. Thank you. Okay, so let's actually see how this works. So stop being so theoretical and actually show you something. So that bundle was called DB cluster is installed. So I will run just that bundle. DB cluster is installed, and my policy file is this nis database demo.cf. -I inform us of what's happening, inform us of any changes you make to the system. Yep, that should do it. So normally the bundle sequence is specified within your policy, but in our case, we specify it on the command line. So you see this is the output from yum-y install. So we're installing the packages, and we're starting the database server.
The question I had earlier was it should first install the server and then install. So how does it know which one to install first in the sequence?
Right. Because good idea. Thank you very much, Max. So the question was, how does CFEngine know the sequence in which to handle these promises. In this case, the sequence is imposed because this promise, the commands promise, is qualified. You see the start underscore Postgres? It's a shorthand for saying there is a Boolean variable called start underscore Postgres. Check to see whether it's set. If it's set, then proceed and run this command, which is the service PostgreSQL start. Now this variable doesn't exist. It's a custom variable that I named. And that variable will only be created when the package promise for the database server cluster is installed. So I have a promise that this package will be installed. If that package is repaired, that means CFEngine saw that this package is not installed and went ahead and installed it. That's a repair. If that repair happens, then that class will be set. And then because CFEngine is cycling over your promises, the next time it hits that command promise, it will take effect. Because now the context for it is going to be true. So it's going to run that command. So it's efficient because it won't try running that command before the package is installed. Does that answer your question?
No, my question was, the order seems like it's installing PostgreSQL first, but then PostgreSQL server. That's fine. You can install it and you won't need to do anything.
Yeah. We don't even need the PostgreSQL package. The only reason I wanted to install this so I can use the command line client to access the database. So yeah, that order doesn't matter. Yes, sir?
So if you swap those two around in the packages, would the installation of the package then also reflect that? In other words, is that the order in the packages section, is that the order that the packages will get installed?
Okay, so the question was, will the packages be installed in the order specified within the packages section? I think so, but let me double check. Let's just swap it around. And we'll put the PostgreSQL package second. So now let's remove PostgreSQL and PostgreSQL-server. So first of all, notice that the order in which it was installed before was first the client and then the server. And that was the order that we had before. So it looks like it, but let's just double check. So no, it's not.
Well, that's the order from Yum's perspective.
Right, right. That's a good point. That's the order from Yum's perspective. Exactly. Yum will handle the dependencies for you because we're telling it yum-y. So you're saying yes. So that means if it has dependency, it will pull them in. Not all package managers do that, but the ones that do it, it's very convenient on one hand because you don't have to track the dependencies, but on the other hand, you can install with a lot of stuff on your system that you don't know about. So cuts both ways. Any other questions about this first bundle to install the database cluster? Okay, we'll continue. Next, I have a promise about a file. And that file is pg_hba.conf, which is the access control list for Postgres. So I have an attribute of that promise, which is an edit line. That means we're going to make promises about the contents of that file. We're going to go inside it and make some promises about its contents. And those edits are summarized with the identifier trust local users. So that describes what we're going to do. And I have a comment here that is accessible when you run CFEngine in verbose mode or debug mode or when you get reports from it. And the comment allows me to document the purpose of this configuration. So not only do you document the configuration just by writing the policy, because when you configure servers by hand and then the sysadmin leaves the company, the next sysadmin who comes in is going to be like, well, why is that server configured that way? There might be documentation. It might be up to date. Or it might be up to date as of 2 years ago and then not updated since then. when in policy-based system administration, your policy becomes a living document. This is the current state of the system. Well, CFEngine takes that one step further and allows you to document the purpose of that configuration. So here, I'm setting up trust local users because I need root to be able to access the database cluster. So CFEngine, which runs as root, can get into the database to set up the database and the table schema. And again, I have a trigger here. If this promise is repaired, then this special context variable reload underscore Postgres will be true. And again, I have a command that will only run if reload underscore Postgres is true, and it will reload Postgres. And the purpose here is I'm going to add a comment to document the purpose, is load the new config file. And I need to show you the details of this edit line. So if you want to, you can go under the hood and you can look at the details of this edit line trust local users bundle. I have two promises here. One is basically delete lines, everything. So first it will empty the entire file. And then it will promise that these lines exist in the file. So we'll insert those lines. So first I have a comment that's a warning that this file is under CFEngine control. Don't edit it directly. Edit it in the policy, or else your changes will get overwritten. And then I set up trust to all local users. So there's different ways you can edit a file with CFEngine. You can edit a single line in a file, or you can edit a section, or you can edit the whole file, or you can use a template. It gives you a lot of power and flexibility, and there's a whole section of the manual on file editing. So here we're just saying replace the whole file and put this in it. Next, I have a promise that the database cluster is running, a promise bundle. So I have two promises here, a processes type promise and a commands type promise. So what a processes type promise does is it checks the process table for a regular expression, which is here Postgres. And we have a special attribute, restart class. What restart class is, if it scanned the process table and didn't find that pattern, then it will set this class. And the purpose of that is, you can then link that class to a commands type promise to take corrective action. So what we're saying is, check the process table. If you don't find a Postgres process, here's the command to start Postgres. So this will repair the case where Postgres isn't running. It's installed, it's configured, but it isn't running. So if somebody accidentally shuts down Postgres, this will start it. Or if the server rebooted and the database didn't start because it's not configured to start on boot, this will start it.
What if it's not running, but somebody's editing the config file? Wouldn't it pass that and then not restart the server?
If it's not if the database is not running and somebody's editing the config file, you mean by hand? Right. Okay. So the idea is when you move into policy-based system administration, all your changes to the system should be done through policy. Now, there is a transition period where people are still used to editing files by hand, but already they've started to use a configuration management system. And it can step on your toes pretty hard. Does that answer your question?
It's more of a, what if somebody who doesn't follow the policy is doing that, then it wouldn't restart Postgres?
Would it restart Postgres? Well, it would restart Postgres if the automated system, CFEngine, if it sees Postgres isn't running, package is installed so it can start it, it will try to start it, it will succeed. Even though somebody might be in the middle of editing a config file, it will start it. Oh, I see what you're saying. You got a command running, vi postgresql.conf. Right, right. That's a very good question, very good question. Yeah, indeed. You can make this, you can anchor the regex, right? Or you can make it more specific, and you should. That's very good.
So what does that mean? The regular expression?
Yeah, regular expression, that's right. One of the few dependencies that CFEngine has is PCRE, Perl-compatible regular expressions. If you want a really small footprint, you can even remove that, and then it falls back to POSIX regular expressions. So the next bundle is database exists. And I only have one promise here. That's a promise to run a command. And the command is create DB, user Postgres, and the database name is conference. That's just the name of my demo database. And we have an attribute here to run this command in a shell, in a separate shell, which allows us to do input-output redirection, which allows the command to run quietly. Because the idea is CFEngine runs every 5 minutes, and this command will be run every 5 minutes. So it will work the first time, but after that, it will start to fail. So you don't want to know about it, that it's failing. You could make this more complicated, and you could check first, does the database exist? And if it doesn't, then create it. But either way, you're going to have to run a command to check if it exists or not. So this might end up being more efficient, if less elegant. OK, and now we get to the, by the way, everything I've shown you so far can be done using the open source edition of CFEngine. This next part is where you get actually inside the database, and that's the enterprise extension. That's the commercial one. So first, I create a variable here. I create a list that contains 2 elements, create and verify. This is because in my databases type promises, I want to do 2 operations. I want to do a create operation and a verify operation. So when you create a list in CFEngine, and then you reference it as a scalar variable, it sets up an implicit loop over each element of that list. So we'll take this promise, and we'll run it twice, once with database operation create, and once with database operation verify. So it's a very compact language, very powerful. It allows you, it has a great economy of expression. So what are we talking about here? We're talking about the database conference and the table speakers. So it uses this database name / table name, like a file system hierarchical expression, just to represent the database name and the table name. So this is a promise about the speakers table in the database conference. Our database operation will be 2 operations. It will be create and verify. So if the table doesn't exist, it will create it. And verify will make sure that the database table exists and matches the schema. Database type is SQL. There's 3 database types supported by CFEngine. SQL databases, which include Postgres and MySQL, LDAP directories, and Microsoft Registry, embedded database. Database columns. So in this table, we expect to have 3 columns. And I have the name of the column and the type of the column. And then the database server, well, the details about our database server are abstracted to a configuration block called demo Postgres server. So let's look at our demo Postgres server. Here are the details of our demo Postgres server. We specify the server owner, the server password, the server host, the server type, and the connection database. That's the database to which we connect in order to create a database if it doesn't exist yet. So here I have 3 tables that I specify: speakers, rooms, and talks. And I specify a different schema for each table. And that's it. That covers all the policy. So now I'm just going to run CFEngine. I want to run the whole policy set, not just the first bundle. I was like, that's too quick. OK, so first thing it did was OK, I'm going to have to scroll back up and show you this. First thing it did was it edited the pghba.conf. Then we ran the reload command to read in those changes. Then, because Postgres wasn't running, it started it. then it ran the create DB command to create our demonstration database. Now it goes on to check the tables. It sees database doesn't contain the promised table speakers. So it creates the table. Table speakers is as promised. So now it's created it, it checks against the policy, it finds it matches. Okay, so let's actually take a look at what did it do. -u Postgres, -g conference. So here's my 3 tables. I've got rooms with 2 columns, speakers with 3 columns, and talks with 3 columns. So it automatically created the 3 tables and set up the schema as I told it to. Now what I'm going to do is I'm going to mangle one of these tables, and I'm going to drop one of the columns. So I'm going to drop the room_name column from the table rooms. So let's say that's a DBA goof. And now CFEngine runs every 5 minutes. And it corrected the goof. See, it put the room name column back in the table. And you can tie it in so if it ends up repairing a table, I can log it, or I can run a command to send an alert. So it can be as noisy or as silent as you wish. So here I'm shutting down the database.
Did you define how it repaired it?
No, that's under the hood.
Okay.
So you specify the schema.
Does it drop the table and recreate it from scratch, or does it?
I can answer that. It does alter table, add column. That's part of what it showed it in this verbose. See, this is how it attempts to. Yeah. So you see it started the database back up. So it repaired from a shutdown, an unintended shutdown. And let's mangle our config in another way. Okay, I'm just going to drop one of these tables. There we go, 3 tables. And one more demonstration. So I'm going to make much more restrictive. I'm going to make the ACL much more restrictive in the pghba.conf. I'm running CFEngine to repair it. And first thing it does is it edits pghba.conf, and then it reloads Postgres. So it rereads the new pghba. And let's take a look. There we go. It put it back. Local all. So your system, when it's under the care of CFEngine, can exhibit self-healing characteristics. Any questions? Okay. Thank you very much for coming. I'd appreciate your time. I left surveys, after seminar surveys. Just give me a little bit of feedback. I'd appreciate it. If you have interest in learning more, please give me some contact information. And if you have any questions, Aleksey at verticalsysadmin.com. Thank you.
So now that we're sort of off the videotape, maybe you didn't want this on the videotape. Could you, I don't know
Yeah, they are. They are. Well, one thing to know about Puppet is Puppet came out of CFEngine in a way, because a Puppet user a CFEngine 2 user was frustrated with some of the limitations of CFEngine 2 and with his relationship with the author. And he said, you know what, I'm going to make my own project. It's going to be better. But a lot of the basic ideas about describing the desired state and convergence to that state are original with CFEngine. So that's where Puppet came from. And a few years later, CFEngine 2 was completely rewritten, re-architected, fixing all the pain points with CFEngine 2 and advancing the state of the art quite far. That's CFEngine 3. That's where it is today. So there's some, I would say the primary differentiator between CFEngine 3 and Puppet today, from a CFEngine standpoint, is CFEngine is unusually lightweight. If you look at its memory footprint, it's unusually small compared to all the other tools out there, including Puppet. So that means it runs faster, takes up less resources, uses less electricity, and the system converges faster to the end state. That's the primary differentiator. Another thing that makes CFEngine different from Puppet is there's a lot of scientific research behind CFEngine. Like there's actual scientific papers and original research work in logic and in computer science that this came out of. So a lot of thought went into the product. I'm not saying anything bad about Puppet. I'm just telling you some unique characteristics of CFEngine. Yes, sir?
I know little about both.
Yeah. Certainly. Yes, sir?
Could you give us an idea what are some of the more advanced features that are supported by the Nova CFEngine as part of the database system?
Oh, okay. Well, I've basically demonstrated what it can do. You can describe database schemas. You can create those schemas. You can verify them on the fly. I've seen a demonstration of against the Windows registry where you can you can cache the current schema, like take a snapshot, and then later you can have another policy that reimposes that snapshot. So if anybody makes any changes since you make the snapshot, they will go away. I don't know if they're supported in the Postgres, against Postgres servers. I just haven't played with that, but I know that generally speaking, the database capability includes this sort of cache and then restore capability. So other things that CFEngine Enterprise Edition Nova can do is the knowledge management. It can give you a graphical report of all your different promisers and how they relate to each other, what depends on what. So that can be very useful for knowledge management. It also has extensive reporting functionality where you get not only reports of success or failure on one node, but across the entire network. And you get a summary for the whole network. You can drill in, look at a particular node, look at a group of nodes. So it's very powerful for that knowledge management type of stuff.